Subscription churn is one of the biggest killers for businesses like Netflix, Spotify, Amazon Prime, businesses that usually run on a subscription. So, as a data scientist, my job would be to figure out who is going to churn and, more importantly, how to stop it. So I decided to do a case study. While I was looking for datasets, I came across this KKBox dataset. KKBox is like Spotify, it's a music streaming platform, but from Asia, and the dataset is really good. I have these notebooks in GitHub. You can just, there will be a open in collab link when you go to the notebooks. I'll link the whole project in the descriptions. Yeah, this is a workflow that we are going to follow. There are 4 notebooks. So we will be going through EDA, Churn prediction, and Causal Inference, and there will be some surprising findings from the data. So this is the dataset. It had 4 CSVs, members, transactions, user logs, train. So I'm doing it on Colab, but if you want to recreate this project, unless you have a paid Google account with more storage, it may not be possible because this dataset is pretty huge. It's like 28 GBs. If you have more space in your drive than the standard 15 GB, then you can do it in Colab and just download the dataset. Otherwise, the safer option would be to run it locally. So I downloaded the data. I used Kaggle's API. This dataset is from an old Kaggle challenge, and you have to join the competition and click on late submission and accept the rules to download the dataset through an API. So when you go into the settings, you will see an option to create tokens, and you can download your API key from Kaggle and then add it to your drive. After the initial download, I have commented the cells for downloading data from Kaggle directly into your drive. So you can just uncomment them if you want to try it. For the initial checks, I just did the basic distribution check, null values, that just basic sanity checks, and one hot encoding for categorical variables, just to see how balanced the data is. So the engagement or user log is the biggest data set. So you cannot load it in the pandas at once. Your RAM will crash. So in order to avoid that, you have to chunk the data and load it into pandas as smaller chunks. That's what I did here. Then I saved. If you're doing a project in Colab, make sure to save your data sets after cleaning or after doing something that takes a lot of time to run. I think this chunking part took me like 45 minutes so on Colab. So just make sure to add a piece of code to save your data set. That's basically the data preparation. You can expect this kind of complications when you work with real data. That's how it is. The data preparation will be the most time consuming part in a pipeline. And I did exploratory data analysis. I handled all the missing values, and we have pretty imbalanced data set because the churn rate is around 6%, which is actually normal for a standard business. Then there is engagement patterns. Then we explored a few features to see how they, to see if there are any correlation. This is all basic exploratory data analysis. Then I tried to figure out if there's correlation between the columns, and based on that we can see last gap days, average list price, average plan days. All of these have pretty strong correlation with churn. Kind of understandable. If they're not using the service that much, they are probably going to cancel their subscription. So from the whole EDA chapter, what we learned is that churn is less about how much users pay and more about their engagement consistency. Usually you have to run some statistical experiments to support your recommendation. In notebook 3, I tried preparing the data set for modeling. Okay, I did not do one-hot encoding before when I cleaned the data for EDA. That is, you don't have to do that, but here I had to encode the categorical labels in order to run a model. So for the baseline model, we are taking logistic regression. It obviously crashed because it's a complicated data set and the relationship is obviously non-linear. The AUC was pretty bad, 0.42. Then I moved to XGBoost and the accuracy shot up and the AUC is like 0.98, which is pretty good. That means from XGBoost you can use SHAP or any kind of explainability techniques to learn more about the features the model prioritized, and a lot of information about how the model made the predictions. From the XGBoost model, we understood the features that XGBoost prioritized. They are auto renew rate, last gap days, cancel rate, number of transactions. So this could be like positive or negative correlation. We don't know that. I have visualized the plot using SHAP, and SHAP does show the direction as well. So you can take a look at it. So based on our modeling and prediction, we understood that the most important features are auto renewal rate, inactivity gap, engagement, stuff like that. So you can plot the precision recall curve from the model to see the best threshold. The default threshold is 0.5. So for a classifier, when the probability is higher than 0.86, so for higher threshold, the precision will be pretty high. Then I plotted the confusion matrix. So the XGBoost model is very accurate at identifying non-churners. It captures a substantial number of churners. False positives are really relatively small compared to size of the dataset. It's a big dataset. If your model misses any churners, then it will be a problem because the company is losing revenue. Modeling is done, and now we move on to causal insights. So for causal inference, we have to design an experiment. There will be a treatment and outcome. So here, correlation is not equal to causation. That's why we need to do experiments. Just because our model used auto renew as a feature to predict the churners, it doesn't mean if we push auto renew on customers who are about to churn, it may not keep them on the platform because correlation is not equal to causation. I used propensity score estimation to identify. So in the experimentation phase, I used propensity score estimation, mediation analysis, inverse probability weighting to mimic a randomized trial. And the result actually shocked me. So the experimentation showed that for forcing auto-renew on churners, probable churners would not stop them from leaving the platform. So actually, the billing option was not the cause, engagement was. I used causal DAG, I drew a causal DAG to explain what's happening. So essentially, the engagement features are driving churning. Auto renew is kind of staying in the middle as a proxy feature. So I guess, I've documented this really well on this notebook. So I guess you'll understand if you go through the text as well. And if you feel like you're stuck, you are not understanding this code, then you can just open ChatGPT, or just you can, when you feel stuck, just clarify that portion and go on. Just ML models can predict who is going to leave the platform, but they cannot essentially say why. Data auto renew as a feature looked really powerful. It was not an actual lever. Features like inactivity gap and engagement related features actually drive churn. So in KKBox challenge, it was not auto renew, it was engagement. But yeah, it looked like it was auto renew. And for prediction, it will work because the algorithm will manage it. But it's really difficult to see it. You can be misled by just looking at the machine learning model and the feature graph. In this case, ordinary is not an independent feature. Thanks for watching. If you like the breakdown, I'll be uploading more data science videos. I'm job searching right now, so I will be sharing tips that works for me. I'm in a new city, new place. If you want to say the full code, I have a link in the description. Go to the repo, go through the notebooks and find the dataset. If it's from a challenge, it will be a messier dataset, which is what you want. Build a good portfolio. So that's all for today's video.